Limit as extends to pi by 2 of secant theta minus tan theta equals option A 0, option B 2, sorry, option C is 2, option B is 1 by 2, and option D is infinity. If we apply the limit directly, we will get secant pi by 2 minus tan pi by 2, which is infinity minus infinity. So to solve this question, let me consider L is equal to limit as extends to pi by 2 of secant theta minus tan theta, and I will multiply and divide this by secant theta plus tan theta divided by secant theta plus tan theta. Now the numerator is in the form of a minus b into a plus b, which is a square minus b square. So given limit becomes limit as extends to pi by 2 of secant square theta minus tan square theta, which is equal to 1 in fact. So limit as extends to pi by 2 of secant square theta minus tan square theta by secant theta plus tan theta, which is equal to limit as extends to pi by 2 of 1 by secant theta plus tan theta. Because we know this formula, secant square theta equals 1 plus tan square theta, that implies secant square theta minus tan square theta, which is equal to 1. So numerator here is 1. Now if you apply the limit, I will get 1 by infinity plus infinity, that is 0 here. 1 by infinity is 0. So option A is the correct choice. Limit as x approaches to 0 of tan 2x minus x by 3x minus sin x. Here also we can solve this problem in two ways. Let us see both the methods. First, let me put x equals 0, that is I will apply the limit, so that you will get tan 0 minus 0 by 3 into 0 is 0 minus sin 0, which is 0 by 0. So we can apply L'Hopital's rule here also. So given limit L is equal to limit as x approaches to 0 of derivative of tan 2x is secant square 2x into derivative of 2x is 2. That is we are applying chain rule, that is d by dx of tan something is secant square something into d by dx of something. So derivative of tan 2x is 2 secant square 2x minus derivative of x is 1 whole divided by derivative of 3x is 3 and derivative of sin x is cos x. As x approaches to 0, that is when you apply the limit, you will get 2 secant square 0 minus 1 divided by 3 minus cos 0, which is equal to 2 minus 1, because secant 0 is 1 and cos 0 is 1. So I have 2 minus 1 by 3 minus 1, which is 1 by 2. So option C is the correct choice. Another method, that is alternate method for solving this question is, let me consider limit as x approaches to 0 of tan 2x minus x divided by 3x minus sin x. I will divide both numerator and denominator by x, so that I will get tan 2x by x minus 1 divided by, let me divide this denominator also by x, so that I will get 3 minus sin x by x. We have a formula, limit as extends to 0 of tan x by x is 1, but I have tan 2x here divided by x. So I will multiply this by 2, that is I will multiply both numerator and denominator by 2. Now you can observe the brackets. The value of that when x approaches to 0 is 1. Therefore, this given limit becomes 2 into 1 minus 1 by 3 minus 1, because limit as x approaches to 0 of sin x by x is also 1. So I have 2 minus 1 is 1 and 3 minus 1 is 2. So in both the ways, answer is 1 by 2. Evaluate limit as h tends to 0 of x by modulus of x plus x square. To find the value of this limit, let us find both left hand limit and right hand limit. Left hand limit will be limit as x approaches to 0 of, that is 0 minus of x by modulus of x plus x square. That is nothing but limit as h tends to 0 of, replace x by 0 minus h, so that I have 0 minus h here, and modulus of 0 minus h plus 0 minus h whole square, which is nothing but limit as h tends to 0 of minus h by modulus of 0 minus h is plus h, and I have h square here. When you take h common, you will get limit as h tends to 0 of minus 1 by 1 plus h. As h approaches to 0, you will get minus 1 as the left hand limit. Now let us evaluate right hand limit, which is equal to limit as x tends to 0 plus of x by modulus of x plus x square, which is equal to limit as h tends to 0 of 0 plus h. Now when you evaluate right hand limits, replace x by 0 plus h. When you find left hand limits, replace x by 0 minus h if x is approaching 0. If x is approaching say a, while evaluating left hand limit, replace x by a minus h, and right hand limit, while evaluating right hand limit, you have to replace x by a plus h. So I have 0 plus h here plus h square, that is 0 plus h square. I have limit as h tends to 0 of h by h plus h square. So obviously when you take h common factor here, you will get h tends to 0 of 1 by 1 plus h, which is equal to 1. As h approaches to 0, 1. So clearly left hand limit is not equal to right hand limit, hence limit does not exist. So option D is the correct choice. Limit as x approaches to 0 of sin ax by sin bx. We have 4 options. Let us simplify this and we can arrive at a conclusion that this can be used as a formula or a shortcut. So let us see how to solve this. Let me consider limit as x approaches to 0 of sin ax by sin bx. I will multiply this numerator by ax and divide by ax, that is x approaches to 0 of sin ax. I will divide by ax and multiply by ax. Similarly, denominator is divided by bx and it is multiplied by bx. Now x and x are eliminated. Now you can observe that the terms inside the bracket will be 1. With the help of this formula, limit as x approaches to 0 of sin x by x is equal to 1. So when you apply the limit, I have 1 into a by 1 into b, which is equal to a by b. So answer is a by b. Suppose if you have limit as x approaches to 0 of sin 6x by sin 7x, easily you can write the answer as 6 by 7. So shortcut formula is limit as x approaches to 0 of sin mx by sin nx is m by n. So option A is the correct choice in this problem. So let us remember this as a shortcut trick for solving such a type of questions. Evaluate limit as x approaches to 0 of sin x degree by x. To evaluate this type of problems, this angle should be in radians, but it is in degree now. But we have formula for radians. When x is in radians, as x approaches to 0, sin x by x is equal to 1. So I will convert this x degree to radians, so that given limit becomes limit as x approaches to 0 of sin of x pi by 180. Now it is in radians. But to bring it to the form of limit as x approaches to 0 of sin x by x, let me multiply this denominator by pi by 180 and multiply the numerator also by pi by 180. So let us see this. Limit as x approaches to 0 of sin of x pi by 180 divided by, I have x here, so I will multiply this by pi by 180 and I will multiply the whole term by pi by 180, so that the term inside the bracket is obviously 1, and when you apply the limit you will get 1 into pi by 180, which is in option B here. Evaluate x tends to a of x square minus a square by x minus a is equal to. So this is a standard form. This is in the standard form. You can recall limit as x tends to a of x to the power of n minus a to the power of n by x minus a is equal to n a to the power of n minus 1. I have 2 in place of n here. Therefore, I have 2 into a to the power of 2 minus 1, which is 2a to the power of 1, which is 2a. So answer is option C. Limit as x plus 2 whole to the power of 5 by 3 minus a plus 2 whole to the power of 5 by 3 by x minus a. Here also, before evaluating the limit, let me put x equals a and I will check whether it takes 0 by 0 form. When you put x is equal to a, you will get a plus 2 whole to the power of 5 by 3 minus of a plus 2 whole to the power of 5 by 3 divided by a minus a. Clearly this is in the form of 0 by 0. So let us apply L'Hopital's rule. Now it is limit as x approaches to a of derivative of x plus 2 whole to the power of 5 by 3, that is derivative of x to the power of or something to the power of n is equal to n into something to the power of n minus 1, that is 5 by 3 minus 1 into derivative of x plus 2 is 1. So limit as x approaches to a of, when you differentiate this, you will get 5 by 3 x plus 2 to the power of 5 by 3 minus 1 into derivative of x plus 2 is 1 minus derivative of a plus 2 to the power of 5 by 3 is 0 because it is constant. Now derivative of x minus a is 1. Now we can apply the limit, so that I have 5 by 3 into a plus 2 to the power of 5 by 3 minus 1 is nothing but 2 by 3. So 5 by 3 into a plus 2 whole to the power of 2 by 3 is in option A here. So option A is the correct choice. If f of x is equal to 2 by 5 minus x when x less than 3 and 5 minus x when x is greater than 3, then we have 4 options. To find the correct option, we need to evaluate the left hand limit and right hand limit at 3, because we have a split function for x less than 3 and for x greater than 3. First let me find limit as x tends to 3 minus of f of x, which is nothing but limit as x tends to 3 of less than 3 is 3 minus, so let me write 2 by 5 minus x. When you put x equals 3 here, that is when you apply the limit, you will get 5 minus 3 here, which is 2 by 2, which is equal to 1. So limit as x tends to 3 minus is equal to 0 is wrong here. Option B is not the correct answer, because as x approaches to 3 minus, the value is 1 here. Now let me find x tends to 3 plus of f of x, that is right hand limit, which is limit as x tends to 3 of, when x greater than 3, I have 5 minus x here, so it is 5 minus x is equal to 5 minus 3 here, which is 2. So clearly limit of f of x, that is left hand limit, is not equal to right hand limit. And here it is given that limit of f of x as x tends to 3 plus is 0, but this is equal to 2. So option A is also not correct, option B is also not correct, and it's very clear that left hand limit is not equal to right hand limit, that is option C is the correct choice. Evaluate limit as x approaches to 0 of cos ax minus cos bx by x square. So let us find the correct answer so that we can use this as a shortcut trick for solving the questions. Here when you put x equals 0, that is when you apply the limit, we have cos 0 minus cos 0 by 0, which is 0 by 0 form. So let us apply the limit by using L'Hopital's rule. So that is limit as x approaches to 0 of derivative of cos ax is minus a sin ax minus derivative of cos bx is minus b sin bx divided by 2x. Derivative of x square is 2x. As x approaches to 0, we get 0 minus of minus plus 0 here by again 0, which is 0 by 0 form. So again we can apply the limit. So given again we can apply the L'Hopital's rule, so that the given limit becomes limit as x approaches to 0 of minus a here. Derivative of sin ax is a cos ax plus I have b into derivative of sin bx is b cos bx divided by 2 here. Derivative of 2x is 2. Now if you apply the limit, I have minus a into a minus a square cos 0 plus b square into cos 0 divided by 2. So cos 0 is 1, so we have minus a square plus b square by 2, which is b square minus a square by 2. So option B is the correct choice. So now if you have a problem like this, that is limit as x approaches to 0, this is an example. You have cos 4x minus cos 2x divided by x square. We can say that it is 2 square minus 4 square by 2. That is I have 4 minus 16 by 2, which is minus 6. So we can use this as a shortcut formula for finding the problems of the type limit as x tends to 0 of cos ax minus cos bx by x square. Limit as theta tends to pi by 6. Limit as theta tends to pi by 6 of cot square theta minus 3 by cosecant theta minus 2. This cot square theta can be written as cosecant square theta minus 1. Therefore, given limit, that is given expression, is nothing but limit as theta tends to pi by 6 of cosecant square theta minus 1 minus 3 divided by cosecant theta minus 2. That is equal to limit as theta tends to pi by 6 of cosecant square theta minus 4 divided by cosecant theta minus 2. You can observe numerator cosecant square theta minus 4 is nothing but cosecant square theta minus 2 square, which can be written as cosecant theta plus 2 into cosecant theta minus 2. That is a square minus b square is a plus b into a minus b. Therefore, given limit becomes limit as theta tends to pi by 6 of cosecant theta plus 2 into cosecant theta minus 2, that is numerator, divided by cosecant theta minus 2 in the denominator. So cosecant theta minus 2 is eliminated. Now you can apply the limit. When you apply the limit, it is cosecant pi by 6 plus 2. We know that cosecant pi by 6 is 2 plus 2 here. So answer is 4. So the value of the given limit is 4.